Dear students, welcome to maths class. In previous class, we discussed about limits, and in this class, now we will discuss about differentiation. And limits is basic for this differentiation. So let us learn. And after the limits, we have differentiation chapter. So if we understand the limits, then it is taken us to differentiation. So next, in this class, the objectives of the class. On completion of this period, you would be able to learn concept of differentiation of a function, derivative of x power n with respect to x, derivatives of algebraic functions. So differentiation, the chapter name is differentiation. Differentiation mainly deal with functions. Differentiation mainly deal with functions. Types of functions: algebraic, y equals to 5x plus c, 7, not c, it is a 7. Trigonometrical, y equal to sin x. Inverse trigonometric, y equals to sin inverse x. Exponential, y equals to e power x. Hyperbolic, y equals to cos hx. What is this? Here a diagram is given. See the figure, and by observation we can say it is a rectangle, and its sides are L and B. Area equals to L into B. Area of rectangle is a function of L and B. A equals to f of L comma B. Here A is a function of two variables L comma B. When there is a change in L or B or both, correspondingly there is a change in A. First point, in many scientific and engineering applications, we deal with the formulas which are dependent on several variables. Number 2, when there is a change in the dependent variable, it should be accompanied with the corresponding change in the main formulas. Third point, the rate of change in one variable with respect to change on the another variable of the formulas can be studied by the process of differentiation. So the rate of change in one variable with respect to change on the another variable of the formula can be studied by the process of differentiation. So recap. First form of the limits, standard forms, that is, we say formulas. Limit n tends to infinity. Here we can say it is wrongly spelled at limit, that is, limit x tends to a, x power n minus a power n by x minus a equals to n into x power n minus 1. Okay, no, here we can say limit n tends to infinity is okay. Limit n tends to infinity of x power n minus a power n by x minus a equal to n into x power n minus 1. Otherwise, if we take limit x tends to a, then it is equals to n into a power n minus 1. So the first formula is a little bit we have to change. Once again I am saying, see, now I am saying the correct way, that is, limit x tends to a, we already know this formula, x power n minus a power n by x minus a equals to n into a power n minus 1. But here, unfortunately, in place of a, x printed or x came. Second formula, limit n tends to 0, 1 plus n whole power 1 by n equals to e. Third, so only first formula, again, once again I am saying, that is limit x tends to a, not n tends to infinity. It is x tends to a, and in the right side n into a power n minus 1, not x power n minus 1. Okay. Third formula, limit x tends to 0, e power x minus 1 by x equals to 1. Differential coefficient or derivative dy by dx, this is given in a white colored background shaded in red ink or pink color. Dy by dx, we say differential coefficient or derivative. Let y be a continuous function of x, that is, y equals to f of x. Let y be a continuous function of x, that is, y equals to f of x. Generally, if x undergoes a small change, say delta x, in its value, y also undergoes a small change delta y in its value, because y is depending on x. The limit of the ratio delta y by delta x as the limit of the delta x tends to 0 and delta y by delta x, here when it exists, is known as differential coefficient of y with respect to x. Here the letters are over printed, so it is look like little bit zigzag. You can see in textbook that is a limit delta x tends to 0 delta y by delta x, when it exists is known as differential coefficient of y with respect to x, and denoted by dy by dx, or we say differential coefficient of y with respect to x. Simply say dy by dx equals to, here we can see clearly, therefore dy by dx equals to limit delta x tends to 0 delta y by delta x. So here we can say differentiation is coming from the limits. So to know the differentiation, the basic point is limits. Dy by dx is also called as y or d of y or f dash of x. Here capital D of y means derivative of y. Note, given y equals to f of x for all practical and theoretical applications, dy by dx represent the rate of change in y with respect to change in x. Definition of differentiation. Let y equals to f of x and consider it as a equation 1. Let delta x be a change in x and delta y be the corresponding change in y. Then equation 1 becomes y equals to 1 becomes y plus delta y equals to f of x plus delta x, and take it as a equation 2. Here y and delta y added both, and in the right side x and its delta x also added. Two minus 1 gives y plus delta y minus y equals to f of x plus delta x minus f of x. Left side terms we taken left side and subtracted, and similarly right side terms of equation 1 and 2 taken right side and subtracted from 1 to 2. So delta y equals to f of x plus delta x minus f of x. Delta y by delta x equals to, here we are dividing delta x on both sides. So we have delta y by delta x equals to f of x plus delta x minus f of x by delta x. By definition, dy by dx equals to limit delta x tends to 0 delta y by delta x. Dy by dx equals to limit delta x tends to 0 f of x plus delta x minus f of x by delta x equals to f of x. So this is the basic point for the differentiation. Here once again I am reading, that is equals to f dash of x. Dy by dx equals to limit delta x tends to 0 f of x plus delta x minus f of x by delta x equals to f dash of x. Differentiation from the first principle is finding the derivative of f of x using the definition. So first principle is nothing but from the limit concept, that is dy by dx equals to limit delta x tends to 0 f of x plus delta x minus f of x by delta x. That is nothing but f dash of x equals to limit delta x tends to 0 f of x plus delta x minus f of x by delta x. So this is called first principle. Of the differentiation. So this first principle is given here in a violet colored background shaded. Applications of differentiation. See here the figure. One L-shaped pipe is there, and in the below of the pipe, under the pipe we can see one glass or flask or like to have the water, one flask or glass we say, by made of the glass. Transparent glass, and that is useful for to take the liquid which is coming from the pipe. So here it is saying if oil is poured at constant rate in a vessel. So here the vessel is looking like a glass. So in the vessel, if oil is poured at constant rate in a vessel, so in the vessel from the pipe the oil is poured, that means oil is coming into the vessel at constant rate. How fast the level of oil increases can be calculated. So when oil is coming into the vessel, definitely vessel's level of oil, that means oil level is in the vessel increased. That increase can be calculated by the differentiation. So here the level is changing according to the oil coming from the pipe or tube. To find the velocity of a plane, so you see the figure here, the plane is moving in air. So velocity means rate of change in displacement, or rate of change of the displacement, rate of change the distance. If a plane has to travel from Hyderabad to Bombay in 45 minutes, what is the velocity or speed required to reach within the stipulated time, and also at what time it will reach with stipulated velocity or speed can be calculated. If you want the velocity of the plane, so here also differentiation is helpful, because velocity is depending on distance and time. So according to the time, the distance will change. So the rate of change in displacement is called velocity or speed. So where there is a change according to the another dependent, then there exists, or there the differentiation will roll. So in these cases also we can use differentiation to find angle between the curves. See the diagram here. Red color lines are indicating axis, or we say coordinate axis, and blue colored curved lines, two are, you can see they are curves and they are intersected at origin. And to find angle between the curves also differentiation is helpful, and by differentiation we can find the angle between the curves. Derivative of a constant let f of x equals to c. Let delta x be increment in x. Then f of x plus delta x equals to c. Since constant cannot change, f dash of x equals to limit delta x tends to 0, f of x plus delta x minus f of x by delta x, that equals to f of x plus delta x equals to, you can write c, and f of x equals to, also we have c, so c minus c by delta x, that is d by dx of c equals to 0. So constant derivative is 0. Derivative of x power n. Let f of x equals to x power n. Delta x is an increment in x. So f of x plus delta x equals to x plus delta x whole power n, because function f of x equals to x power n is given. So in left and right, both the place, we are replacing the x with x plus delta x. So we can have like this: f of x plus delta x equals to x plus delta x whole power n. F dash of x equals to limit delta x tends to 0, f of x plus delta x minus f of x by x. That implies f dash of x equals to limit delta x tends to 0, x plus delta x whole power n minus x power n by delta x. That equals to limit delta x tends to 0, x plus delta x whole power n minus x power n by x plus delta x minus x equals to n into x power n minus 1. So this is, you can say, d by dx of x power n equals to n into x power n minus 1. We know how to find the limits, and in previous classes we discussed about the values of the limits for the given function. So here directly taken. So in the background, it means after the calculation this value is given, that is n into x power n minus 1. Here in the violated background shaded, we can see d by dx of x power n equals to n into x power n minus 1. So this we are written based on first principle. So like this we can frame number of formulas by using first principle. So always we cannot go through first principle. Some we did and we can take as a direct formulas of the differentiation. So derivatives of standard functions. So these standard functions, now you understand how it came, means how it got and how they are equal to this right side parts, means in the background we are go through the first principle, and after the finding the limits we got. So to easy we are taking it into the formulas or standard forms, so we can easily do the problems or apply directly. So dy dx of x power n equals to n into x power n minus 1. Number 2, d by dx of root x equals to 1 by 2 root x. Next, d by dx of 1 by x equals to minus 1 by x square. Fourth, d by dx of 1 by root x equals to minus 1 by 2x into root x. Algebra of derivatives. If u comma v are functions of x, then derivative of sum or difference d by dx of u plus or minus v equals to du by dx plus or minus dv by dx. So this is comes under property. Plus or minus we can separate for each. Here you can see in a yellow color background shaded. Second property, derivative of a product or product rule. So this is not like above. We can see here d by dx of u v, that is u into v, equals to u dv by dx plus v du by dx. So observe here also it is given in a yellow colored background shaded in a rectangular box. Next point, in particular d by dx of k into u, k is here constant, so we can take constant outside, that is k into du by dx. You can see in a yellow colored background shaded part. Derivative of quotient, or we say quotient rule, that is d by dx of u by v. See, uv is different and u by v also different. So d by dx of u by v equals to v into du by dx minus u into dv by dx by v square. So this is also the formula, so you have to remember, and this is also given in a yellow colored background shaded in a rectangular box. Solved problems. See, when you know the formulas or standard forms, it is very easy. So look here, d by dx of root x equals to d by dx of x power 1 by 2, that is, it is look like d by dx of x power n. So the formula is n into x power n minus 1. Here n is 1 by 2, so n into x power n minus 1, that is 1 by 2 minus 1, that is 1 by 2 into x power minus 1 by 2, that equals to 1 by 2 into root x. Second, find d by dx of x cube minus 4x square plus root x. Here in the question it is typed in first term x power 2, that is not x power 2, that is x power 3, so it is wrongly typed. So you can see here in the answer or solution, so it is not x square, it is x cube, or we say x power 3. So d by dx of x power 3 minus 4x square plus root x. Here we have subtraction and addition between these three terms. So for each term we can apply, or we can separate the differentiation, or we can write like this, that equals to d by dx of x cube minus d by dx of 4x square plus d by dx of root x. Here again the power 3 is typed as a power 2, so you adjust it, you can understand it. So actually it is a 3, I already told you. So x power 3 means it is in the form of x power n. So x power n we can write n into x power n minus 1. So here x cube derivative is 3 into x power 3 minus 1, that is 3 into x square. And come to the second term, minus d by dx of 4x square. 4 is a constant, so write it outside of the differentiation, that is 4 into, then we have d by dx of x square. Again here x square means it is in the form of x power n, so n into x power n minus 1, that is 2 into x power 2 minus 1, that means 2 into x plus root x derivative is 1 by 2 root x, so 3x square minus 4 into 2x plus 1 by 2 root x. So 3x square minus 4 into 2, 8x plus 1 by 2 root x. Next question, number 3. d by dx of 2x plus 4 into 3x square plus 7x. Here two factors are given, so we have to apply UV formula because they are product rule. So consider solution. Consider that is d by dx of what is given here taken 2x plus 4 into 3x square plus 7x. We know that d by dx of uv equals to u into dv by dx plus v into du by dx, and it is background shaded in yellow colored background shaded. So here u means 2x plus 4 and v means 3x square plus 7x. So according to product rule, we can write 3x square plus 7x into dy dx of 2x plus 4 plus 2x plus 4 into d by dx of 3x square plus 7x. Here you can observe uv we can interchange vu also because there is no problem, because one time we are differentiating to u by putting v outside and another time differentiating v and putting u outside. So uv or you can say vu. Here first term taken as a v and second term taken as a u, so that's why it is written as a this. So whatever it may be, we can conclude that 2 plus 3 is equals to 3 plus 2. So here the two terms, the summation, and in the summation we can interchange. At the end there is no change, so u dv by dx plus v du by dx we can write in interchange also, that is v du by dx plus u dv by dx. So we can change their places. At the end there is no change. So like here we can write, or we are seeing here, first taken 3x square plus 7x and then the remaining part we are differentiating, and in the next second term, in the first we differentiated part we took here outside, and first leaved part we taken here as a differentiation. So the main theme is from the two factors, if you are doing differentiation to one factor, then second time you put it outside and do which is put outside in first term, that should be differentiated. So after differentiation we can see 3x square plus 7x into dy dx of 2x means 2 and dy dx of 4 is 0, so 2 plus 0 2, and plus second term 2x plus 4 into dy dx of 3x square means 3 constant, x square derivative is 2x, so 3 into 2x 6x, and 7x derivative 7, so 6x plus 7. And next question, find dy dx of 3x minus 5 by 6x plus 7. Here if you observe, the function is in the form of u by v, so we know that dy dx of u by v equals to v du by dx minus u dv by dx by v square. So here u means numerator and v means denominator. Like product rule, we cannot take the zigzag way, or we cannot take any one is a u, so that is not possible here. So compulsorily numerator is u and denominator is v here. So next, according to the u by v, we can write this, that is 6x plus 7 into d by dx of 3x minus 5 minus 3x minus 5 into d by dx of 6x plus 7 by 6x plus 7 whole square. So that equals to 6x plus 7 into d by dx of 3x is 3 and 5 derivative is 0. So 3 minus 0, 3, and minus 3x minus 5 as it is, and dy dx of 6x is 6 and 7 is constant, so constant derivative is 0. 6 plus 0 we can write directly 6 by 6x plus 7 whole square as it is we take it. So this is the u by v method, and after simplification in the numerator we get 51 by 6x plus 7 whole square. So now quiz, dy dx of x power 7 equals to 7 into x power 6, that is c, and dy dx of 1 by x square. So we can see answer is D, that is minus 2 by x power 3, and dy dx of x cube is 3x square, so answer is D, and dy dx of 1 by x into root x equals to minus 3 by 5, minus 3 by 2 into x power 5 by 2, minus 3 by 2 by x power 5 by 2. So dy dx of cube root x equals to, you can say 1 by 3 into x power 2 by 3. So in this session you have learned the following: concept of differentiation of a function, derivative of algebraic functions, problems of algebraic functions. So assignment, find the derivative of the following with respect to x. So this is the differentiation, and you try the exercise problems also, and before going to exercise observe the example problems, then do the exercise problems. If you have any doubt, ask me and we will discuss some more.